I keep on talking about gravity, but what is gravity? Imagine you're standing on top of a building. If you were to step off it, you would fall down. You would get pulled downwards. If you ask people what is gravity, most of the time they would say, oh, gravity is something that pulls you downwards. Well, that's true in this case here. But what happens if it's in this case here? Let's say this is planet Earth, and you're standing here. That's okay because it's pulling you downwards here. But what happens if this guy here is standing on the other side of the world? If your theory up here, gravity is something that pulls you downwards, then it's going to break down because this guy here, he should be falling off the Earth. So what's going on? So when you say gravity is something that pulls you downwards, then it's true in this case, but it's not true here. So you could refine your theory if you like. You could say, oh, gravity is something that pulls you towards the center of the Earth. Then here it would be a better theory because if this person is standing here, it's pulling you towards the center of the Earth. So that's okay. So a better theory would be gravity is something that pulls you towards the center of the Earth, rather than, oh, gravity is something that pulls you downwards, because here it would break down. But if you refine your theory and say, oh, gravity is something that pulls you towards the center of the Earth, it sounds better. But it's not actually, if you look at this scenario here, this is Earth, okay? So your theory, so a better theory is gravity is something that pulls you towards the center of the Earth. That's a better theory, isn't it? But then what happens if, say, a moon is here? Okay. If Neil Armstrong, if he's standing on the moon, so if the theory of gravity is something that pulls you towards the center of the Earth, is true. If we're all on Earth, but if Neil Armstrong, if Neil Armstrong was standing on the moon here, if our theory is correct, he should be falling towards the center of the Earth, towards the center of the Earth here. So gravity breaks down. If you say, oh, gravity is something that pulls you towards the center of the Earth, that theory is wrong. Because here, if you're standing on the moon, you wouldn't get pulled towards the center of the Earth. You would get pulled towards the center of the moon. So what's going on here? So you could say gravity. So what is gravity? Something that pulls you to the center of the Earth, or something to the center of the moon? So we need a theory that would work for everywhere, if you like. So what is gravity? Well, gravity, you can imagine it as this. Gravity is when two bodies have a heaviness or mass. Let's use the word mass. Mass is like a heaviness. Let's say you are standing here. You as a person have a heaviness. There's a heaviness. Let's say you have a mass. Use the word mass. Okay? You have a mass, a heaviness. The Earth also has a heaviness. It also has a mass. So when two things have masses, for example, M1 and M2 here, when two things have some has a mass, then they get pulled towards each other. So you being you having a mass and the Earth having a mass, you would get pulled towards the Earth, and the Earth will get pulled towards you. So when two things have a heaviness, they will get pulled towards each other. So for example, if you take two dice into space, okay, hang on, two dice into space, this die here will have a mass, okay, let's say M1. This die here will have a mass as well, let's say M2. Because there's a heaviness of this die, and this die also has a heaviness, then they're going to get pulled towards each other. So gravity is is really something that pull when two things have masses, they will get pulled towards each other. So a person, a person standing on Earth, here, this person here, there exists a mass for this person. There exists a mass for this Earth. So they will get pulled towards each other. Now, a person on the moon, well, if you're standing on the moon, sorry, let's say here, if you're standing on the moon, this person has a mass, the moon has a mass, so they get pulled towards each other. But the thing is, there's a famous formula here. Hang on, let me just write this down. Gm1m2 over r squared. Okay, hang on. Let's say this is the Earth here. This is a person here. This person has a mass. The Earth has a mass. So they get pulled towards each other. But there's this r thing in this formula here. It's saying that well, the gravity. If you're on Earth here and you're standing on Earth here, the center of the Earth and the Earth. This distance here is, let's say, r. Okay. The gravity, the strength of the gravity depends on the distance away. So like if you're in space here, hang on, let me draw it again. This is the Earth, the person here standing on the Earth, and there's another person standing here. Okay. Well, gravity here, this is a distance r. This is, let's say, another distance, a different r. Let's say r2 here. Because this person is closer to the Earth, r is quite small, so the gravity here will be stronger. Okay, this person here, there's also a gravity that exists between this person and the Earth. So, but because the r here, the distance here is a lot bigger, so the gravity will be weaker. So this person will still get pulled towards the center of the Earth. But the point is, the gravity here is a lot weaker than here. Why is it that hang on. Why is it that, say, like, this is Earth here, and this is the moon here? Why doesn't this person get pulled towards the Earth? Well, because the r here, you got to take the distance r here into account. The person that's standing on the moon, the r here and the r here, hang on, this is r1, r2 here. Well, the distance here is a lot smaller. So for this person here, so the gravity towards the moon is a lot stronger than the gravity towards the Earth. There is a pull, by the way, towards the Earth, but because this r here is so big that it makes the gravity toward the gravitational pull towards the Earth so much weaker compared to the gravitational pull of the moon. So so like hang on, if you're on Earth here, okay, and the moon is here, let's say there's some water here, the ocean here. Here the moon is actually pulling the water towards the moon. Okay, and if you look behind the moon, there's the sun, and here the sun is also pulling the water towards the well, here you've got the pull of the moon here plus the pull of the Earth here, the sun here. So the tides on here will be a lot stronger than if you were, let's say, the sun over here. Let's say this is Earth here. Oh, sorry, but a bit big. Let's say the Earth here and the moon here. If you look at the water here, well, the ocean here is getting pulled towards the sun, and it's getting pulled towards the moon here. What I'm trying to say is that when the moon and the sun lines up here, the ocean, the height of the ocean would be higher than in this scenario here, because this scenario here, the moon. Well, if you look at the ocean here, it won't be that high because It's just using the gravity of the moon. Now, if you are looking at this here, even though these, my point is that if the Earth is here, when the moon and the sun lines up, the pull will be a lot bigger than if the sun is on its own pulling towards the sun, or the moon pulling on its own towards here. So the gravity, well, overall gravity is when you have two bodies, let's say M1 or an M2, gravity always exists between two bodies which have masses here. Okay, so gravity is something that exists between two objects that have masses. Okay, in short. Okay.